All right, so I'm going to pause this. Let's make some materials. What do we want? We want a material for the ground and rocks, really. We'll just do one for both because it's going to be pretty abstract and who cares. We're going to need that. We're going to need, well, let's just start with that. So go over the matte area, the principal shader we just made, call it ground. We can put it on our render ground area either by dragging it over or finding it as usual. We can turn this back on, see what it looks like. It's not going to be that interesting. I want to make it brown, and I want to make it brighter, and I want it to be pretty rough. Maybe like pretty rough. 0.8's good. Reflectivity can stay at 1. So there you go. Good enough. Take a screenshot of that. Pause it. What else do we need? We need a better light, so we can actually evaluate this better. So drop down an environment light over here on the object area. Unpause this. Already looks a billion times better. Environment light for the uninitiated is instead of it being a simple light coming from a single source, it is instead of a sphere. If you can imagine this blue sky that we have here, imagine it's just white everywhere. So we don't just have light coming from one direction casting a shadow. We have light coming from every direction. So only the things that are really in crevices are remaining shadowed. So that's cool. We're going to play with this a lot, probably. For one, we want it to be brighter. It obviously renders, it takes a lot longer to shade. But the river looks cool. It's like ceramic or, I don't know, porcelain, which is maybe the same thing. So that's cool. So we've got a light now. That's enough for us to say that our ground still looks pretty good. I'm going to go grab a liquid now, a basic liquid. Hopefully none of this changes too much in the new Karma render that's coming pretty soon. I understand that the render is still going to be Vex-based, and that's what these are. These are just, VOP networks, Vex operators. So I imagine even if it's not Mantra, the shaders will still be set up pretty much the same. So I'm not too worried about that. Anyway, the liquid shader's a little weird. There's some weird default settings in there. Put it on the render liquid exterior, like so, and put the uniform volume on the interior, like so. Let's render with that. Let's see what that looks like. Cool. So that's certainly something. It's going to be a lot slower now. For one, we have to do refractions, we have to do reflections on the surface, and we have to do volume calculations inside. If you don't recall from the previous lesson, uniform volume is not a shader for volumes. It is a shader that treats polygon surfaces as volumes, or rather it treats them as the outer boundaries of a volume. So when the rays shoot out from the camera into the scene and they hit this polygon surface, they say, oh, don't shade me the way you normally do, which is that it's flat and has a normal and we reflect light and all that stuff. We now march the ray through the geometry bounded by this and set off our secondary rays and all that. The normal stuff that is what volume shading is built on. Watch the volumes lessons for more info there. Okay, so that's not so great. Kind of a step back, if anything. Two things we need to do. One is, well, first I'm actually going to turn off the volume thing here, the uniform volume. I'm going to say, let's just not do this for a second. Let's just focus on this. In fact, I'm going to literally say, don't render. Oh, we should disable these just in case it tries to do those. So, render thing here, click that, turn off the interior one. Good. So it'll just render faster. And that's what we want. We want this to render as fast as possible while we work out the various issues with it. So one thing we're seeing is that this looks blue. Why does the liquid look blue? The liquid looks blue because the default setting is that. I think somebody thought that it's like, oh, well, people will think that water is blue. Water is blue because it reflects the sky, which is blue. Water is not inherently blue, which is what this is saying. So what we want is make this white, which is the, which is 111, which is basically, nothing in a sense. So now it's white, but it's still kind of milky looking. The water should be clear. The reason why is because by default, we have enabled diffuse on. It has a diffuse component. Really, the water should just be a reflection of the environment around it and a refraction, which is when you see through the water. By default, we have enabled diffuse on, though. If we turn that off, now it's actually clear, where we can see through the water in a normal, sane way. So you can see the rocks and such. And we do have the reflections, and we do have the reflections, so it's all correct so far, which is pretty cool. So that's something. It's a big improvement from here, where it just had this painty blue kind of residue on the surface, which is really weird. So that's cool. So we can let that finish or not. I'm just gonna take a snapshot and not. We can already see where we come from. Look at this. Look how far we've come. Very good. And so much more to go, though. Now, there's an idea that liquid should have a frothy color also. That's this thing here, vorticity to diffuse intensity. Water is clear typically because there's nothing in it. The water that comes out of your faucet, for example, should hopefully not have anything in it. Now, if it's churning, though, in certain areas, as we know that it is, especially right around here, it's churning quite a bit. So remember when we turned on vorticity on the solver back here? I just turned the simulation off so it doesn't try to simulate to frame 72. Back here on the particle vorticity, we turned it on. It just recorded it, and that's great. So if we go to liquid cache, and we go here to our surface thing, now it's packed right now, so let's unpack it over here on the side. I want to look inside it. There it is, the vorticity attribute. I want to see it. Click the eye, click vorticity. And we can see something going on. We can see it's kind of white along these crests, which is kind of cool. Click on the little visualizer thing here, or rather right-click it, and you can see vorticity has been added and turned on. Click on the pencil and turn off auto. Let's say min and max, and let's find out what's the real range here. If we look at the material, by default, it's looking for going from 0 to 10. So let's just start there. So anything that's red is the upper end of that range. So that's all going to be rendered. If I turn this back on, vorticity to diffuse intensity, it will say, okay, we don't want a diffuse sheen all over it. Maybe only have it where it's very diffuse, or where it's very a high vorticity amount. The reason for that is it simulates having lots of little air bubbles. But we don't want it everywhere. We just want it in these very specific regions. And I do mean very specific. We're going to have our own, the actual whitewater solve later on. So I don't want to see it everywhere. I just want to see it in the most extreme areas. So this is actually pretty good. Maybe we can go down a little bit. Nah, that's already too much. I want it to be like that. Now these numbers in here on the edit visualizer don't matter. It only matters what we put here. So copy those values. Now that we found it, we needed to do that in order to figure out what would make sense. So come back to the render view. Apparently frame 72 is where we were. So I'm going to turn this back on. And now we should see, if I switch back and forth, some of this diffuse action. As usual, I'm going to put this to 1 to just blow it out to really see it. We see an issue though. It is doing it, We can see some of these crests now, but it's kind of doing it everywhere, isn't it? But this says to just do it from 25 to 50. Well, that's because of another odd default choice. This remapping here, this ramp, says that at the lower bound and below, always have at least 0.1 of it, which is then multiplied by this. So this should be set to 0. So now we actually have what we want, where it looks the same as it used to, except now it has added, only in the high vorticity areas, some extra whiteness. Now 1 is way too high, so let's just go back to where it was, 0.1. And I'm serious when I say I only want to see this a little bit. See that? It's such a small amount. We're going to have actual whitewater later on. We don't want to make our liquid any milkier or weirder than we have to. So we've added it in a few spots. Cool. If you want, you can, try to find it. You could increase it by going here. You could maybe try to capture more areas by doing something like that. Whatever you want to do is fine. I'm just going to say, I'm going to say 20 and 40 is actually good after all. 20 and 40. It's not really adding that much anyway. Just a little bit. So that's cool. A little word of warning. All these settings that we're going to find for the whitewater and for the vorticity related stuff, all of that's going to go out the window if and when you want to up-res this again. Again, unfortunately, the behavior and various relative attributes change quite a bit when you change resolutions. So, just saying. Nonetheless, we need to set this stuff up, and then we can just tweak the attributes later on. Cool. So there you go. So we've got that going. Take a snapshot. A couple more things I want to do before we finish this chapter are, right now, we're using a just generic white color. We should try using one of the environment maps that come with Houdini. So click on the HFS, Houdini File System, HDRI, High Dynamic Range Image. Choose Lenong or one of the other two. They're all pretty different. If we unpause it, you'll see it's now will be shaded quite differently. Apparently it's darker and bluer. So that's kind of cool. Why did this happen? If we go back out here, there's an image everywhere all of a sudden. This is the image we loaded. Instead of it just being white everywhere, which although we didn't see it is what was happening, now we have an image everywhere. That's pretty cool. So this is going to be reflected in the surface of the water. The fact that there's a lot of blue sky, even in this blown out area, it's still bluer probably. All of that is going to contribute to a more interesting and natural looking lighting solution. So snapshot that for sure. You might as well turn on clip to positive Y hemisphere because we're never going to need to sample anything below here. Even our viewport looks kind of cool now. And if yours doesn't, you can click on go from here to here. Things are, no, I don't want to make a null. I did it again. Things are looking pretty cool, but it's kind of dim. It was definitely nicer before. I'm going to say, let's try doubling the light here. See what that gets us. So now it's a lot brighter, which is cool. I don't know. If you press I and you look at this, you can see how bright it is. Looking at the luminance value there at the end, it's like about half right now. It's not too bad. Snapshot that again. Might go 50% more on this just to see what that gets us. The brighter this is, the more interesting stuff is going to look in terms of like the reflections on the water and the fact that it's a bright day now. If we look back in here, everything's going to look blown out, unfortunately now. So blown out, in fact, that I'm going to say on the environment light, you can turn that off. You can say enable light in viewport, turn that off. Or you can click this or go back to this setting to turn that off. In any case, So having it be bright, don't be afraid of going bright. It's easy to get like used to the first values you had. Even this before. Now it's like very vibrant and much more interesting. And I also know that we're going to make this water darker when we turn our uniform volume back on. That's pretty cool. Once again, from here to here to here to here. Not going to lie. The reason why I keep doing this is because I like to put this in the preview of the lesson. And I know Houdini is going to crash eventually from this interactive render, and I want to have it recorded before it does. All right, cool. Let's do a couple more tweaks with this.